Okay, let's look at great circle sailing now. We're going to look at the basic spherical triangle where you have the pole A and B. And before we sort of name the values, let's look at a sort of very simple drawing really. There's the pole there going down to the equator, and we've got latitude A and latitude B. So when we draw a spherical triangle, which would be PAB in this instance, you can see that PA is going to be 90 degrees minus latitude A, because from the pole to the equator is 90 degrees. Whatever our latitude is there, we subtract from 90, and that would give us our value PA. And similarly, PB is going to be 90 degrees minus latitude B. So in this drawing here, we've got PA and B. The value PA is the initial latitude minus 90. PB is the final latitude minus 90. You see I've put plus signs there, and that's because you may have a situation where your final latitude, or indeed your initial one, or probably your final one, is going to be in the southern hemisphere. In these examples, we're assuming we're in the northern hemisphere, and our latitudes are north. So your initial latitude might be a northerly latitude at position A, so that would be 90 degrees minus latitude A for PA. But for PB, then that's going to be 90 degrees plus latitude B, because now our latitude B is in the southern hemisphere. So PA would be 90 degrees minus latitude A, but PB, as you see I've actually finished the triangle off there now, PB is going to be 90 degrees plus that latitude B. So when you're going from north to south, you have to add them. So I've written there the values of the spherical triangle. P, of course, this value here, that's the D long, the difference between the two longitudes. PA is the initial latitude plus or minus 90, PB final latitude plus or minus 90, and AB is the distance of the great circle. And of course, the great circle is the shortest distance between the 2 points when you're going over a long distance, and we've got it's curved that way in the northern hemisphere, PA to B. A, this angle here, will be your initial course, and B will be the reciprocal of your final course. So you can find your initial course and your final course and your distance that you travel. If we were to have what's called a maximum latitude that the great circle reaches, it's known as the vertex. So what happens is because of the curvature of the Earth, as that's your course there, at some point your latitude's going to increase and reach a maximum, and that there would be known as the vertex. Okay, that's the vertex. So that's the point at where you reach a maximum latitude. And obviously at this point, the great circle runs east-west. Okay? And if we were doing a composite great circle course, that represents an 090 or 270 degrees course, which we'll look at a bit later. And I've done a little drawing here just to emphasise 90 degrees plus latitude A in this instance, and 90 degrees minus for latitude B, for PB and PA, and drawing the equator, just to emphasise that's why you have the plus and minus. That's your basic spherical triangle. So if we now look at the formulas that we would use, you get most of these formulas anyway, but just have a look. That's P, A and B. I've indicated there D long, initial course, final course, distance, what these values are. And to get the distance, cosine AB, it's when you do this, you've got to be careful with your calculator. That's in brackets cosine P times sine PB times sine PA. So you would do all those within a bracket and solve that, and then plus, and then you'd put these two values in a bracket as well. So it's important that when you use your calculator, you can do this the correct way. So you'd put in your calculator, you put cosine P times sine PB times sine PA, and then you'd have equals plus, then bracket cosine PB times cosine PA, close bracket, equals, and then get the cosine of that, and that would be your distance. Similarly, to get your initial course, when you're using your calculator, that's cosine PB minus, and then brackets. So you wouldn't put cosine PB minus cosine PA times cosine AB. It's cosine PB minus the value that is actually in this bracket here. So you'd have to have cosine PB on your calculator minus bracket cosine PA times cosine AB, close bracket. and then you'd have equals divided by, and then again bracket sine PA times sine AB. And you do a similar calculation for your final course as well, ensuring that you use your calculator correctly. And the only way to get confident with this really is practice. You can also calculate your courses using the ABC tables in Norris as a quick reference. And for example, for the initial course, A, initial latitude is going to be latitude, final latitude is going to be a declination, and D long is going to be your LHA. So you've got latitude, declination, LHA, use the three formulas and you can find the course. And similar calculation of course for your final course using the final course values the other way. So that's how you would solve a quick solving of the initial and final courses. But one thing to be very careful of there is the way that you use the calculator to solve these problems. It can be a bit tricky at first, but once you get confidence with your calculator, you should be okay to solve the problem.